Welcome, everybody, to another episode of Houdini Secrets Live. Welcome. My name is Chris, and I will be your Houdini host for this afternoon. We're an hour later today because of the FIA capstone presentations that were going on earlier today, and I wanted to dive in and catch a hold of those while they were still going on, so I pushed the Houdini Live session 1 hour in order to give all of the capstone presentations their course due. Good job, all the students at FIA. Your capstone games really looked impressive. Very good job. You're making all of us look very, very, very proud. All right, so let's get going. Now, this is going to be part 2 of our presentation where we are dealing with viewer states. Well, actually, interactive interface. Interactive interfaces at Houdini. Now, we gave a few basic simple interfaces last week, but this week, we're going to be focusing just on viewer states. Now, viewer states are a little bit more complicated, but they're kind of a whole beast unto themselves. Let me see if I can get things going. Okay, we don't see, oh, it's because we're not broadcasting. Hold on. Let's get things broadcasting here. Right. Let's get this shoe on the road. All right. Oops. Let's get this going. Hopefully that's working. Let's see if there's actually showing up anything. Oh, it is not. It's showing the wrong thing. Let's see. Is this showing then? Wait, actually, that's what I want to see. And so let's double check to make sure that this is... No, that's not it. Is this the lecture deck? Uh-huh. Yeah, that's what we want. Yes, it's good. Okay. Look at that. These are my inspirations for the day. These gentlemen they didn't even know me, but they were very helpful in establishing our viewer states. But anyway, let's get things going before we actually dive into Houdini. Let's talk a little bit about viewer states. Now, viewer states, as presented last week, are any type of mouse and keyboard or tablet interactions. Now, they're all very cool, and we're going to just show one type of interaction because they are, well, actually, they're complicated, and they take me a little while to understand, and it took me kind of a while to figure out these, but they're actually very, very cool. So it's always I always love the opportunity to get a chance to learn something new and totally cool, and these are really wicked, and I think you'll see in just a little bit. They're very, very powerful, but they do require some Python understanding. So we're in the last couple of weeks, we've been doing a lot of VEX programming, which is good. You know, VEX is kind of like a herald back to the C days without any kind of pointers. But now we're going to be dealing with VEX and Python at the same time. So it's kind of a little bit of right brain and left brain kind of situation where you're going to need to deal with both languages going at it full bore. I'm going to go a little bit slower, so the lecture is not going to have as much content, but I'm going to go a little bit slower to give everyone a chance, an opportunity to deal with this kind of like brain switching back and forth between Python and VEX, because even for myself, this gets to be a little bit taxing after a while. But anyway, let's talk more about the viewer states. Now, viewer states are awesome because they allow you to do a lot of things like promoting things like display handles. You get to interact with the geometry. As you can see, we're going to interact with some geometry today. We can just display guide geometry, which is an addition beyond the regular geometry. We can respond to user interactions. Things like extra menus, you can get that. You can choose separate geometries. You can do undo blocks, and you can operate on multiple context levels. What I mean by that is, like, suppose you want to work in the object level, and then you want to work in the SOP level, and then you want to go over to USD, and you want to work in the LOP level. Yeah, you can do that with viewer states, and it's all really cool because it handles these multi-contextual awareness environments. But I have to admit, these are the gentlemen that made this all possible. I would not have been able to get through all of these examples within the time frame if it wasn't for these guys. This is Simon Verstrate. Sorry if I am barbecuing your name. Anyway, you can check him out on ArtStation. That's Cyver.artstation.com. Check him out. He's got a lot of really good tutorials, and he's got a lot of really cool content on there. And he goes into a little bit more detail of some viewer states going into a kind of a different direction. And also, I got a lot of inspiration from another fellow, Ricardo Ponce, and his website is Particula, particula.org. Now, he had some very interesting stuff, and he gave me some inspiration to create something really cool, which I never knew possible before, and that is to create actual user feedback within the SOP level inside Houdini. Now, this is really cool. I've been looking to try to do this in Houdini for about, well, this was 1996, so it's about, about 25, 26 years now. I've been wanting to do this since the old Prisms days. And so this is very cool. I didn't know this was possible, but thank you, Ricardo, for showing me that it is indeed possible, and it is way cool. So much tip of the hat to these gentlemen here. So thank you very much for your contributions. Go check them out. These are really good websites. And we're going to show two examples today. And they're both going to be interacting with the mouse. So we are not going to do anything special with any selections. We're not going to do anything with any extra menus. We're not going to do anything with any special context. We're just going to keep things simple, just working with the mouse input, which is itself kind of involved. So you're going to see what you got to do for this. Now, if you want any specific help on any other of these very dynamic areas within viewer states, there's about 6 or 7 of them. But if you want me to create a lecture on these, get in contact with me. Send me an email. Let's talk about it. Let's create something going there. I love to promote your content. So if we can get something that you guys are going to want and need, let's get in contact. Let's create something very cool together. These two examples, they're relatively easy as far as the viewer states are concerned, and in my humble opinion, are a good introduction. There's the easy one, and then there's the harder one. And with that said, let's get going and drop into Houdini. Okay, let's see. Yep, nope. Okay, we've got that going. All right, so let's drop into Houdini. And voila. Okay, very good. Let me double check to make sure that I do in fact have Houdini up and going on here. Okay, no, I don't want this SOP window. I want Houdini, darn it. I got to stop doing it. One of these days, I will learn. All right. Okay, yeah, we do have Houdini. Now, this means, as we have Houdini, that means I can now get naked. Because it is probably about 90 degrees in my studio suite here. And with no hope of getting air in here, and having clothes on is just a royal pain in the butt. So, doing Houdini naked, yet once again. Ha 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 ha. All right, I'm afraid I'm going to lose the window again very soon. Oh, wait, no, I don't have to. I can just go to here and go to this one. Yes. Okay, very good. No, that's not what I want. Let's go this. I'm going to lose a Houdini again very soon. Yes, but we can get them back very quick. All right, cool. All right, so, no, this isn't going to work. Okay, I can see this now, so we're going to have to do this on the low key. All right. Okay, so what we're first going to do is how to use the mouse wheel in order to move our object around. So if you can, work from your project that you created last week for the user interfaces. I'm going to drop into the project that I started using last week and set projects, and it's already thinks that I'm in it. So let's see, let's open a recent file, and oh, that's right. Let's see, interactive interfaces, hip, discard and open. All right, there's our teapot that we were working from. And there we are with our cannon. So I'm going to leave that as is, and that's good old Roberto. Okay, very good. Now I'm going to see if we can create a new object. So I'm going to create just a new geometry SOP, and I'm just going to call this viewer states, because we're going to create a couple of digital assets in the SOP level. And the first one, let's see if we can create a, I see, let's see if we can create a spiky ball. So I'm gonna, if you go check out the SideFX website, they have a spiky ball that you can download, and it's really cool, pretty cool. Let me see if I was successful in downloading it. Okay, Geo, share, yeah, there it is. Okay, there it is. There's our spiky shader ball. And it is good. So what we are going to do is we are going to reduce its geometry using the mouse wheel. And you say, how are you going to do that? Well, we're going to get to it. Okay, so I've got my object. Now, this will work with any kind of geometry that you want. If you want to throw Roberto, you want to throw the squab, you want to throw Piggy in there, it's all good. That'll work good, but I'm just going to use the shader bot as it exists here. And from that, I'm going to append a poly reduce SOP. Beep. Poly reduce. And I'm going to keep this into the percentage to keep. And if you see, we can scroll that down. And then as we scroll down, our object decimates and it loses control. And it can get down pretty low, you know, right down to about, oh, let's see. Yeah, this is not bad. Yeah, this is close, yeah, under 8%, and it's still maintaining its overall presence. So that's all pretty cool. So what I'm going to do is I'm going to leave this environment just as is, and then I'm going to put I'm going to select it all, and then I'm going to put it all into a subnetwork. So I'm going to click the little subnetwork little dealio here. That's a Shift plus C. And then I'm going to call this guy Spiky Ball. All right, I've got the spiky ball created, so let's go ahead and turn this bad boy into a digital asset. So I'm going to right click on that guy, hit create digital asset, and there we go. And I am going to put that in there, and I'm going to say you go to, I'm going to go, okay, $job / HDA / spikyball.hda. Okay, why not? I'll click accept. And we're thinking, aha, there we go. Now, it looks like I embedded the spiky ball inside of the digital asset, which is okay for this situation. But if we had wanted to have some kind of abstract geometry going into this, then we could have just left the spiky ball out of it and had that come into and put this onto one of our maximum inputs. We're going to do that for our second example, so I'm just going to leave things as it exists right here. All right, I'm going to click apply so that we've saved everything, and then we are ready to rock and roll. Now we're here inside of the interface. What we want to do is promote a couple of things. And the first thing we're going to do is we are going to go to our poly reduce. Let me make this a little bit smaller. Yeah. All right, here we are. We're going to drop in there, and here's our poly reduce. And so there's percentage to keep. I'm going to leave this at 100 for now because I want to start at 100. But I'm going to grab this percentage to keep, and I'm going to drag it and drop it right underneath root. And so there it is, percentage to keep. And it's called percentages. I'm going to hit apply so that it is now an embedded channel inside of my network. All right, very cool. So that is good. Now I'm going to return back to here. Now I'm going to go back to interactive. And now here's viewer states. Now we saw viewer states, shelf tools, handles, and selectors. Now we played with handles last time or last week. Now we're going to deal with viewer states. Now most of these other viewer states can deal with selectors and shelf tools as well. Now we're not going to have a chance to get to that today's lesson, but if you want me to go into that into the future, get in contact with me, make a request, and we'll see what we can do. But anyway, for this case, we're going to go to viewer state, and then we're going to click new, and we come up with that. And so I'm going to go with spiky ball, name spiky ball. I'm going to call it spiky ball viewer state. And you do want to create a unique name for your viewer state, even though it's different than your actual digital asset. It kind of helps do that. And Houdini gets a little bit confused because this creates a separate Python library inside of the digital asset. And that's why you got to have it, give it a unique name other than that, because it gets confused between the Python libraries. But we're going to leave this as blank. Now, if you want to go and play with other things, you can see there's all these other types, and I said that there were about 6 or 7. Looks like I lied. According to this, there are about 11 variations to deal with. So lots to learn and lots to go over, so you can really go nuts with these digital assets, and I'm really actually very excited to learn more about these. But I'm going to leave this as blank for the time being. I'm going to click accept, and with that, we should get, a very simple Python template. And that's pretty much where we start from here. Now, once that's said, we have to then, inside of a web browser, we then have to navigate to, I want to navigate to the Houdini website in order to get some documents on how to use the mouse wheel events. And I'm going to go ahead and go on to that. And let me see if I can get that going here. All right. Okay, very good. Here we have some code here. Now here's the address. This is sideeffects.com, docs Houdini, HOM, states events.html wheel. All right, see this part right here where it says def on mouse wheel event? Go ahead and grab this whole function, because this is going to be a supporting method inside of our state, or our class that we create. I'm going to hit Control C, and then I'm going to put this bad boy away. And then I am going to drop that right there. Now this is Python, gang, so remember the spacing really matters, and it's very, very delicate, in other words. So I'm going to click accept just to see if there's anything wrong with that, because I want, if there's any kind of syntax errors, I want it to pop up immediately so that we know exactly which one it is. And so for the state, here's the name of our class that we're going to use, and it's just state, and that's just kind of abstract. And what did we call this? I called it spiky ball viewer state. So I'm going to make my class called spiky ball viewer state, just to complement it. So spiky ball viewer state. Okay, cool. Now this is the name of our class, and just creating the class isn't good enough. You have to tell the template where to find the class. And so come down here where it says create viewer state template, go and find a line that says template.bindFactory, and there should be the word state in there. Replace the name state with the name of the class that we just changed there. Spiky ball viewer state. I'm going to click accept. Okay, very good. So we should now have stuff that gets actually going. So I'm going to accept this and see what's going on here. So let's all test to see if this actually works and then does something. If we go up and we press spiky ball, and then if I hit the enter key, and then it goes on and it does something. And did it do anything? I do not know. And it did not print there. So I don't know if it actually did anything. So let's go and check to see what happened. I don't think it did anything, but let's go in my type properties and see what it was supposed to do. So print, scroll, this, okay, I didn't move my mouse wheel any, so maybe it was supposed to do things, but maybe it didn't. But anyway, here let's explain this code a little bit that we copied here. Inside Spiky Ball Viewer here, this has a callback event called onMouseWheel event. You can't change this name. This name is what Houdini expects you to provide to it so it knows what to do. And inside of that, it receives argument of self and quargs. Okay, for those of you that don't remember what quargs stands for stands for keyword arguments. So what quargs is a dictionary that Houdini maintains for all of its digital assets. And it has all of the kind of global variables that Houdini uses in order to keep track of everything. And so it is one Python dictionary that is encapsulated, and it keeps track of all the important stuff that you want to know. Now inside of that, we say device equals quargs UI event. Now a UI event is it's an object class here, and so what we're going to do is we're going to call forth, okay, give us the UI event associated with UI event. Okay, makes sense. And then we're going to ask for, okay, give us the device. Now the device from the event handler is what we're going to get, so we're going to end up with this device. And then we're going to poll the mouse wheel. Okay, if the mouse wheel is actually doing anything, then we're going to print out some of this. If the mouse wheel isn't doing anything, we're going to leave it just as is. So I'm going to hit accept again, and now I'm going to hit enter. And so we're in that. And now, if you see I move my mouse wheel, if I scroll it towards me or away from me, it's 1. If I go towards me, it's a -1. So it's either a 1 or a -1. Okay, cool. That should be enough information for us to go ahead and start coding with it. I'm going to hit escape, go back into my type properties. And let's keep things going. All right, so we have that. So I'm going to go ahead and put a comment on it because I don't want it printing out all over the place. But for debugging purposes, I kind of like the scroll thing around it. And so what I'm going to do is I'm going to create a pointer or a variable that points to this particular digital asset. And I'm going to call it me. I'll say me. This is me. And I say me equals quargs. And then I'm going to say, which node am I? Okay, so this statement right here is going to return back with current node that I'm currently at, which is this particular guy. Then I'm going to say, I'm going to query what the with the current value of my percentage is. Now, when you say percentage, what is that? Remember, when we dragged from the SOP of the polyreduce, here is our percentage variable. You see it's called parameter : percentage. So it's called percentage. We dragged it and exposed it right up here to the root. And so now it's tucked in here and it's called percentage. So what we're going to do in here, we're going to query the node and say, hey node, give us the current percentage value. So I'm going to call it percentage equals, and I'm going to say, okay, me, okay, and then we're asked for which parm are we talking about? So parm, and then inside of that, I'm going to put in an open quotes, close quotes, and inside of that called percentage. So this is when you put parm, it's looking for an actual string. And then we're going to say it dot eval. And just to test and make sure that this works, let's do a percentage to see if when we do a mouse roll, if it actually works. So I'm going to go print, and we're going to go percentage, colon, and this is going to be a float, so I'm going to use %f, and I'm going to close quotes and say dot format and percentage. All right, so that's going to display whatever the percentage it currently is. So I'm going to click apply, and then I'm going to go up here and then hit enter to go into the node. And now it says, oh, percentage $F. All right, so I did things wrong. See, this is the problem. Remember how I said that you got to keep the two languages separate, Vex and Python? I just used the Vex context. And so the Python is actually looks like this. Instead of the percentage %F, I should have just put open and close squirrely brackets. Click apply. Now, if we go ahead and hit enter, and now this is, okay, it says bound method, percentage, okay, this gets it right, but this isn't quite what we want yet. I want it to evaluate, and I forgot to tell it to evaluate. Great, all right. See here, I called the parm percentage. I say, okay, yeah, give me the actual thing. And so what Python did exactly what it was told to do. It returned the address of the actual variable, it's the parm variable itself. But I don't want it to return the address. I want it to evaluate it. So I'm going to type eval. And when I put the open and close parentheses around it, it's going to evaluate. I'm going to click apply. And now let's try to hit enter. And now try it again. Now, there it goes. And now, no matter where I put the scroll, it's putting it at 100%, which is exactly what I want because we haven't told it to change any. All right, that's fine. So let's tell the percentage to actually change. So let's tell this. So I'm going to go me dot parm, and we're going to call it percentage. And I'm going to say dot set, because what we're going to do now is we're going to set the parameter value associated with that. And what we are going to call it, we are going to do the percentage plus that scroll amount that we just grabbed here. So I'm going to type in percentage plus scroll. Okay, so remember, scroll is either going to be +1 or -1, and percentage starts at 100, and it's going to cap at 100, so it will either go up or down. So I'm going to click apply. I'll click accept, and now when I hit spiky ball, I'm going to hit enter, and now, as you can see, as I wheel down, you can see the percentage of the spiky ball reducing. And if I go in the opposite direction, there it goes. And so this changes not only in the display here, but it displays in the print there, and this percentage to keep this changes as well. And so this is working pretty much exactly as expected. Now what I'm going to do is I'm going to get rid of that print statement because I no longer need it. And I'm just going to comment it out because I like to keep my comments, my print statements around because I often do a lot of debugging. So here is our viewer state. Not too terribly difficult. All we did was actually change a couple lines from what was given to us from the example. So really not too bad. So I'm going to click accept, and I'm going to hit the save node type, and then match current definition to lock this bad boy. And now, whenever we hit enter, we go into the viewer state, we can change the resolution just by wheeling up or wheelie down. All right, that was a pretty easy example, but let's go into a more complicated example. And let's suppose that we wanted to actually paint on a surface. So we're going to be using the mouse information again, and what we're going to do is do a little bit of ray tracing. We're going to project from the mouse position, or where our cursor is, onto the surface. And then wherever that surface is, we are going to highlight that primitive, and then we are going to give it some kind of random color. So we're going to keep things simple again here. And so you can do whatever you want. We can do this to primitives. We can use this to points. We can use vertices or objects. But because this is a basic template, I'm just going to do simple and keep it with some basic primitives. Now, we are going to be using something really cool in here, which is kind of an additional bonus. I didn't know that I was going to discover this, but when I was doing the research on this, I figured out how to create a feedback loop within the SOP network. Now, like I said, I've been looking for how to do this for maybe the last 25 years in Houdini, and even before that using prisms. And I didn't know it was possible. So I think you probably could do this since about version 17, I think. But I didn't know about it, so I'm really excited. So you learn something new every day. So I'm going to go ahead and drop in, let's see, I'm going to just create a grid. All right. And I'm going to put the display on there. And we're just going to leave the grid alone for the time being. All right. Then I'm going to lay down a subnetwork. And then I'm going to call this prim select. All right, now this is going to be our new digital asset. So I'm going to pump this guy into here. And then I am going to change this guy into a digital asset. So I'm going to right click, press create digital asset. And I'm going to change the name and move this over here. So it's $JOB/HDA, prim select HDA. Okay, good. Here we go. Now, because we have one input and a maximum input, I'm going to leave this all as one. The maximum inputs equals the minimum inputs equals the maximum outputs. So that's all good. I'm going to leave that as is, and I'm going to click accept just to keep things going. So this is a little bit more complicated. So what I'm going to do is I'm going to do this in two stages. First, I'm going to create the feedback loop inside of the digital asset. And once the feedback loop is established, then I'm going to go and create the viewer state in order to control it. So let's dive into our prim select digital asset and create this feedback loop. All right, so what we're going to do is I'm just going to be real simple here. And so what I'm going to do is I'm going to just drop in a vertex wrangle and drop that right in here. And I'm going to do something really simple, and I'm going to call this guy paint white, because that's all we're going to do is paint the vertices white. So I'm going to just type in here at capital C lowercase d, so our diffuse color equals set, and it should be 1, 1, 1. All right. Okay, so everything is looking good here. No problems. Everything got colored white. This is good. Now, just to make sure that this is working, let's change the color around a little bit. Let's make the blue value 0. And if I press this, it turns yellow. Okay, everything is working exactly as expected to. Now, from here, this is kind of like what I like to try to do. I like to try to create memory buffers or anchor places where I can hook onto things. And so I'm just going to drop in a null here. So I'm going to go tab, null. And this null is going to be an anchor point for future use. So I'm going to change this word to clean geo. So no matter what happens, I'm going to end up with clean geo when I get to this point. Now, I don't have to freeze the data yet, but I'm going to color this. I'm going to color it yellow. And then I like to make it a little bit unique in the look, so I'm going to press Z and give it a shape, and I'm going to give it a curved shape so it looks round. Okay, now here's our anchor point. So this is going to be the place for, this is going to act as our geometry buffer for our viewer state. Okay, now this is the thing that, you know, I'm not always up on the most recent versions of Houdini. I don't know how long this has been around, but I found out about it, and I think it's really cool. They have this thing here called a stash node, and a stash node is kind of like locking off a SOP, but it's actually storing the SOP dynamically. Okay, it's basically a lock on a node without having to press the lock button on and off. So the node is called stash. So drop in a stash SOP. And there we go. And I am going to call this guy feedback, because this is where my feedback is going to come from. And then what I'm going to do is I'm going to put in a switch if stop. Switch if. So this is a conditional if statement that is done there, so I don't have to write an expression for this. So let's take a look at the contents of this switch if SOP. So we're going to say use second input if all the conditions are true. That's right. And we're going to put the test input, and we're going to test it. I want to do is that if there's value or if there's content inside of the feedback, go ahead and use the feedback. But if there's no feedback, go ahead and use the clean geo. So I'm going to say test input, second input, and the test type is an expression, but we're going to use element content or element count. There we go. And then we said the number of points, anything will work. In group, we're just going to leave that as equal to. We want it to say, it says enable when the number of points is greater than 0. Okay, cool. You see right now the switch SOP is like focused on clean geo because clean geo has data, but the feedback SOP doesn't. If we click onto here, we're going to see that it's got 0 information. It is just an empty container right now. So it is not looking at the feedback, it's looking at the clean SOP. All right, cool. Now we've got the data coming in, so let's go in and paint some primitives. I'm going to click onto here, and I'm going to add, this time, a primitive wrangle. And, okay, let's see. Let's contact this. Let's call this paint me. Paint me. Okay, we're going to cycle through this primitives. And so what we're going to do is we're going to grab whatever's in the group content. So we've got about 80 boxes in here, 80 primitives in here. Let's go for primitive 69. Okay, we're going to say like, okay, let's get another one. Let's say maybe, I don't know, 32. 69 and 32. Okay, we want to color these ones. So what we want to do is whatever comes through into the group, we want to paint. In other words, so I'm going to get first what primitives are actually in here. So I'm going to evaluate this group expression. So I'm going to say int prims, because these are my downloaded prims. And I'm going to, since this has to be an array, we have to use the square brackets in it. And the function that we want to use is called expand prim group. Expand prim group. Thank you. Houdini will fill it in for you, and we want it from input 0, and we want it from our group parameter. So it's CHS, because we're going to be bringing in a string. And inside the CHS, we're going to put open and close double quotes, and then we're going to put, what's the name of this? It's just called group. Okay. All right. Excellent. Okay, so this is called group. Okay, so we have prims on there, so we should be good to go. And let's just test to make sure that this is actually working. And so I'm going to put in a printf statement. This is different than Python, mind you, because we're in Vex now, printf. And then inside of that, I'm going to put open and close double quotes, and then we're going to put prims, colon, and then this is where we're going to have to declare this. Okay, we're going to be getting integer data, so that's %d. And then we have to terminate every line with a \n, which means line return. Okay, primitive, prims. Okay, so what we want to do is put dot, let's see, dot, okay, no, we don't want a dot, we want a comma, prims. And then we're going to put a semicolon around that. Okay, I'm going to hit Alt. Okay, let's see what happens. And okay, it's not going to print to this window. What we have to do is print to some other window. Now, since I called Houdini from my Cygwin window, I'm going to go and open my Cygwin window, and then we hear it as prims now is displaying 69 and 32. That's exactly what we want to. So it is working the way we expected. All right, now if you used a printf statement inside of yours and you didn't use Cygwin, then you probably got to print it. It may have actually printed out to the console or to another window that you call that. I'm not sure. It kind of like depends on which machine that you have. So it's printed out someplace good, but the important part is it printed, and so I'm going to comment it out and leave it there. Okay, so what I'm going to do is that since this attribute wrangle is going to go through every single primitive. So I'm going to check, which is the current primnum, currently found, or am I inside of this list called prims? So int pos, and this also returns an array, pos equals, and the function I'm going to use is the find function, and say, okay, find. Okay, inside of prims, am I going to find my prim number? Prim num. That looks good. Okay, cool. Now what I'm going to do is I'm going to test its overall length. So that means is that if I found something, means if primnum is one of my selected primitives, then the length of my pos variable is going to be greater than 0. So that's just a simple test. It's like, did you find anything? So if, open and close parentheses, len, L-E-N, open and close parentheses, and inside of that, if the length of pos and outside of that is greater than 0, then we should have an open. So let's test to make sure that this is working. So let's go ahead, and if it is in there, so let's do another print statement. And so printf, and inside the double quotes, and I'm going to say primnum colon, and once again, this is another integer, and we do \n to get the line return, and then it is comma, and we need to find the primnum. So let's say at primnum. Well, actually, it's going to be stored in the pos. So let's go pos. But since I know it's only going to be one variable, since we're going over primnum over there, so this is always going to be just one value. It's 0. All right, click that, and I'll click this. Okay, no errors. Let's pull up my window. And there we go. Primnum 1 and then primnum 0. Okay, 1 and 0, they're definitely found in here. So they're going to actually match what we're going here. Okay. Somehow think that this didn't work quite as expected, but I'm just going to play around with it and keep going. Okay, I'm going to turn that off there. All right, so what we're going to do is that once we found a primitive that matches, what I'm going to do is I'm going to change all the vertices of that current value to I'm going to change it to the whatever color I want. So what I'm going to do is go through every single vertex inside of every one of my polygons, and I'm going to change this color. So I'm going to first create a random color. So vector, I'm going to call it rand color equals rand. And what I'm going to do is I'm just going to put in, this doesn't exist yet, but I'm going to use a variable that I'm going to use in the future, and it's going to call count. And since it doesn't count, since it doesn't exist yet, it's going to come through as a 0. But I'm still going to use it. So rand inside of there. And inside of that, I'm going to go chi, because this is going to be an integer. And the path for that is going to be ... count. Now we haven't created count yet, but that's okay because this is going to come through 0, and I don't want this to be rand's color. I want it to be rand color. I'll click through on that. And so I'm going to go say set vertex attribute. All right, set vertex attrib, and we want the 0th input, and we're going to change the diffuse color of our vertices, CD, and then which number do we want? We want the primnum, so at primnum, and oh, we have to do this 4 times. Oh, silly me. So I'm going to go say I, because I know this is going to be a for loop here, but hang with me, folks. I just don't want to do this again. I'm going to say rand color. Rand color. Okay, I forgot. Every single, okay, we're in a primitive, but a primitive all has 4 vertices. So I'm going to leave that at that. So we're going to create a for loop here. So for, and inside of that, int I equals 0 to initialize my for loop. I'll say if I is less than 4, because I know it's always 4, and we'll go with I plus plus. And then I'm going to indent the set vertex attrib over just a wee bit, and then contain that in there. So here we go. What we're going to do is we're going to go through all the vertices, and we're going to change all the vertex colors to whatever rand color is up here. So let's go ahead and hit Alt, Enter. And how are we doing here? If I click this, there we go. And it's 2 of my primitives have been changed color. And let's turn on the primitive colors and say it looks like 32 and 69 have been changed. Okay, this is good. This is working. Let's create something else. Let's try 12 and, oh, I don't know, 76. Well, there you go, 12 and 76. It works. Does it work with 3? Let's try 10. Yeah, okay. So our little attribute wrangle definitely works here. So this is a good thing. All right, so we are styling. Okay, there's one thing I forgot to tell you guys. And now this is kind of funky. Now this is actually in the documentation inside of Houdini, and so it's not on crack or anything. If you are using this expand prim group, and if you have a group with nothing in it, that kind of means that everything is selected. And that's going to present a thing. See what happens when I put nothing in here? It all trains over. And okay, so what are you going to do about that? Well, I'm just going to put a test right at the beginning of my attribute wrangle to just kind of test it and make sure that that condition doesn't exist. And if it does exist, if there's nothing in here, just go ahead and return. So if I'm going to say CHS, so CHS string of, inside of that, we want group, double quotes, group, double quotes. If CHS group equals, now make sure to go equals equals because this is a comparative equals. So equals quotes quotes. Then I'm going to say go ahead and just return. And now if I go ahead and hit Alt Enter, it turns back to white. So now it is okay to have nothing into this group. All right, we are styling. All right, I've got my attribute wrangle. I've got paint me, and then I'm going to create another null here. And then I'm going to give this a name called Painted Geo. All right, so wasn't this clever of me? Okay, let me change the color of this around. So this is going to be yellow. And let's make it round. All right. As I was saying, wasn't that clever of me? We've got clean geo and painted geo, so we've got two different places with it. If clean geo is selected, then we know we're going to get clean geo coming all the way through here. And if it's painted geo, then we know it's going to come over here. So we now have two different places that we can draw from so that we have our clean painted buffer. Okay, so guess what, gang? This is it. This is our feedback loop. You're going, hey, wait a second, what do you mean? Well, we're going to have to create the viewer state in order to keep things going. And so that means what we're going to have to do is expand a little bit on our digital asset. We need to expose some of the assets that we just created. So I'm going to go open my type properties. And I'm going to make this a wee bit smaller, just to make it look good. And so what I'm going to do is expose some parameters that we're dealing with here. We're only going to deal with 3 parameters here. So I'm going to go and grab the stash. And look at here. There's not much here. So there's stash input, which is the little button that you press that kind of creates the freeze frame. This kind of but we don't have to do that. It's actually stored right here in this variable right here, geometry stash. So I'm going to grab geometry stash and put it under root. And so it has the variable name of just stash. All right. Now, all we have to do now is expose. We have here the group, because we want our viewer state to kind of say, okay, once we start selecting stuff, go ahead and put it in this group. And whatever gets put into this group is going to get painted. So I'm going to grab group and just drag this off into the root, and it's going to be there. All right, so that's pretty much all that we wanted to expose from this network, but I'm going to add one more thing. Remember how I said that we're going to use count here, and we haven't defined count? So what I'm going to do is I'm going to grab an integer and put that on here, and then I'm going to just label this as count. And just like from Sesame Street, we have the count. Every time we create a new selection, it's going to go 1, It's going to go 2. It's going to go 3. And yeah, you get the point though. So this is just going to be a variable that is going to keep track of everything. Now, it's not imperative that we see all of these exposed parameters. If you want, you could click on each of these bad boys and you can make them invisible. And so you see they're invisible. They're still there, but you just can't see them. And this is kind of tricky sometimes because when you're creating the final asset, people are going, oh, where is it? I can't see it. And they say, oh, it's invisible. Oh, I forgot to check for that. However, when you're debugging, it's my best suggestion is leave the invisible stuff on for the time being so that you know it is, because it's really easy to forget what you've created there. So I'm going to go ahead and click accept and to be going here. And so we have our digital asset here. And we're all good. And there's our 3. There's our stash, there's our group, and there's our count. Okay, we've got all of them. So let's go ahead now and create our viewer state. I'm going to go back into my type properties. And then I'm going to interactive, and then select viewer state, and then click new. Now I'm going to leave this one as blank again. Now we could use some of these other ones, but honestly, I don't know how to use all of these things. It shows some cool stuff in here, but I'm just going to leave it blank because it's the easiest for the time being. And so as far as the prim select is concerned for the name of my viewer state, so I'm going to call it prim select viewer state. Hit Control C. Paste that in there, the label, and click accept. And there is our default code that is pretty much exactly the same that we created it for the on mouse wheel. All right, now we're going to go ahead and create a brand new class. So I'm going to change the name of my class from state, and I'm going to call it prim. Oh, I like to enable, capitalize my classes. So I'm going to capitalize this. So prim select viewer state. And then I'm immediately going to copy this and then paste that right here where it says bind factory. All right, oops, that would have produced an error. Okay, we got that, clean it up, hit apply. Okay, now I like to just test the dickens out of this stuff, so let's just test to see if this works. If I hit prim select here, hit enter, we click accept. Okay, nothing happens, no errors, no nothing. Okay, hopefully we're good. If we had introduced any kind of errors, it would have freaked out and it would have told us. All right, let's go back into my type properties. Now, here's our class called prim select viewer state. Now we're gonna keep track of some data, and I just need to keep track of just a little bit of data in order to start painting stuff. So the first thing I want to keep track of is which node am I currently on? So we're dealing with 2 different levels here. We're dealing with the digital asset layer and we're dealing with the class layer. The class may not understand what the digital asset is, so let's get a pointer to the digital asset itself. So I'm going to go I'm going to go self dot me, that means my node, equals, I'm going to say self.node, that's right, equals, I'm going to leave that for none because it hasn't been set yet. And this is just going into the constructor, and we always want it to construct and have a value of nothing to begin with. And the next parameter we want to keep track is the pointer to the geometry. We need to keep track of the geometry of whatever node that we're working on. So self dot my geo equals, and we're going to make this none also because we don't know what that information is going to be yet. And also, we're going to keep track of which primitives are currently selected. So I'm going to go prims. These are the current ones that are going to be selected, but we're going to leave that as a open variable. So it says prims equals open and close square brackets. That means we're going to create it as a list, but it is going to have nothing inside of it. All right, now when we did it on the previous example, we copied from the Houdini documentation on the mouse wheel event. We're going to do something similar to that, but let's see. Before we do that, okay, this should work. And so if I click apply, you know, everything is copacetic. And so we should be good to go. Let's just test this again real quick. I like to just test things. Test, 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 test. Okay, nothing happens, nothing barfed. Okay, we are good. Okay, now the first callback that we're going to have to create is to tell our viewer state what to do once we mouse over and put the mouse inside of the viewer window, because that actually triggers an event too. So we have to tell it what to do as soon as the cursor enters into the viewport. So def, and the naming here is very important here. So we're going to have to say on enter. Okay, that's a name that I can handle. It's real hard for me to mess that one up. I'm going to do, and the parameters for that are self, and then you named it Quargs. Once again, what does Quargs stand for? That stands for keyword arguments. So send the golden dictionary of lots of groovy stuff. All right, now this is in Python, so we're going to enter a new block of code, and we don't do that with curly brackets, so that we do that with a colon. And so we've got our colon in here. All right, and so I'm going to say, now I'm going to say, okay, me, which is my, which current digital asset we are looking at, and we're going to get this from Quargs. So say me equals Quargs. And because it's a dictionary, we access it through the square brackets. And then we want, okay, what node am I currently at? Okay, that's going to tell me who I am. That's kind of like an identity thing. It says, okay, yeah, make me me. All right, cool. So I'm going to go self, which is now part of the class, self node equals me. All right, so the current node being worked on is me. All right, I know this stuff seems a little bit redundant, but what I'm doing is keeping track of the pointer to my class so I can always return back to it. And now what we're going to have to do is grab the geometry. So self dot my geo equals, and now, so let's grab my geometry. And what do I want? Oh, let's see. Where do we want the geometry from? If we go into our, we want the clean geometry, because that's the stuff that's just been pulled in from whatever is going there, and we know it's going to be white, and we know it's going to be clean, and we know it's not going to have anything funky going on with it. So let's grab that node's geometry. So I'm going to say me, because this is my network, me dot blah 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 blah, me interstate, me dot node. Yeah, man. Too many windows. Me dot node. And which node do I want? We want the clean geo node. Clean geo. Okay, we want the clean geo node, and then we want its geometry. Okay, so what we did said, okay, take whatever the geometry that's inside of clean geo, and then put it into self my geo. Look at that. Good thing I looked that over, because otherwise we wouldn't know where the geometry is. And then, okay, we now have some geometry that we can play with. And so what we're going to do also is we're going to create a little interactive prompt. And our little interactive prompt will tell us what to do. As soon as we hit the enter key, it's a little bit of a reminder on how to use our digital asset. And so we're going to call our little prompt by first, we're going to say with who.undoes .disabler. And I tried to look this up, and I really couldn't find out much information about what this is all doing, but this is the way you do it. But with this information, or with this library, what we're going to do is we're going to do self.setPrompt, and then we're going to send it the quargs. Okay, self.setPrompt we have not created yet. So well, what are we waiting for? Let's go ahead and create this function. Okay, def set prompt, and we're going to identify it. We first have to put on our self, and then quargs is the variable that we're going to be pulling in. All right, colon sets the block. All right, then we're going to just say prompt equals and we're going to create it 2 lines long. So hang with me, folks. We're going to go to this open and close quotes, and we're going to say 1.lmb and drag. And that's going to give us the selection, and I'll call it selection to be painted. Okay, so that's going to set the color. And now I'm going to hit \n, which means carriage return, or in other words, line return. And we're going to go 2. And actually, I'm just going to leave it just as is for now. I'm just going to keep that nice and simple because this could get more complicated. So we have just our prompt equals a string there. And then let's call the scene viewer. Okay, self.scene_viewer dot set prompt message. All right, and then we're going to send it the prompt. Okay, you're going to say, hey, wait a second. Where's scene to viewer? Up here, we declared scene to viewer to be the scene viewer as called from the constructor. So this is part of our class, and so we should be good to go. So let's go and test to see if this thing is actually working. So if I hit apply, now nothing should happen here. Now, but if I go and hit enter, there it is. Our little prompt kind of showed up. LMB and drag, selection to be painted. Now nothing happens when I'm just dragging in this, yes, but our prompt does work. Okay, so we are good to go. So we are styling. And while working on this, I found that one of the things that I like to do was create a reset button. A reset button, you say, yeah, because I tended to, I'm working with a feedback loop, and the feedback loop tends to store additional information that I didn't necessarily want to keep track of. So the reset button kind of just cleans everything. You know, it's just, you know, I'm just going to put the reset button on there, and it's just going to go in and just wipe everything out. Just set things back to where they are. And we do that by creating a call down here in the create viewer state template. And I can go in and hit that. Okay, so what are we going to do? Template dot bind parameter, parameter. Okay, bind parameter, and we got to call it who dot parm template. It's going to give me a hint. Parm template. Okay, parm template type. Yes, that's what we want. And which template type do we want? We want a button. Okay, cool. So Houdini is helping us out here. Thank you very much, Houdini. And we're going to name this button reset. So name equals reset, and our label is going to equal reset, but with a capital R. All right. So let's test to see if this works. I hit apply. We're good. And now if we hit enter, check this out. We've got the LMB, the little prompt here, and there's our reset button. Okay, nothing's happening up there, but we know that it works. Sweet. Okay, let's keep on marching along. We're doing great. We've got our asset button created. Now let's create a handler for the reset button. So what we want to do is if we hit the if we hit this, then we want to just set everything back to normal or back to where it started off. So what we're going to do is create something like our constructor, but a little bit different. So I'll go def, and then we're going to call on and this is a callback that is set forth with Houdini, so we have to use its naming convention, but it's on parm change event, and it also is, the parameters for this one are self and quargs. All right, cool. We're in here now, and the first thing I'm going to do is identify who me is, so I know who I am. So me equals quargs, open and close square brackets, and inside of that, open close double quotes, and I'm going to put node. So I need to know who I am because I am schizophrenic, and I need to know where things go. Okay, me equals that. Okay, and now I need to know what the name of whatever are they. So I'm going to go parm name equals quargs, and then we're going to ask for its parm name. So it is here, open and close double quotes, parm underscore name. Okay, parm name equals that. Okay, good, cool. That's all that we really need. Now we could get all of the stuff that is available from quargs, but the name is all that we need at the moment in time. We could get the more parameters, we could get values from it, we could get just about whatever we want from that dictionary, but name is all we really need now. So let's just test to make sure that the name equals reset. So if parm name equals reset. Okay, if we are indeed working with the reset button in case something else found its way into there, what are we going to do? Okay, first we're going to delete whatever's in the primitive array. So del for delete, self.prims, and then open and close square brackets, and we're going to put a colon in here. Okay, in case you've never seen this before, whenever you put the colon in there, that means don't destroy the actual variable itself, but get rid of its contents. So what this colon inside of this means all of its values. So that, in other words, what we're doing is we're deleting all of the values inside primitives without actually destroying the variable. See? Kind of cool? All right, cool. But we know what me equals, so I say me dot parm, and we have, what kind of parms do we have again? Let's go up here, parameters. Okay, we've got stash, we've got group, and we got count. We want to initialize all those to nothing. So let's first start with group. So group is the first parameter we want to do this, and we want to do set, and we want that to be none. Okay, me.parm. And then the next one we want is stash. And this also set to value of none. Put nothing in there. Make sure there's got nothing. Nunca nada. And now we're going to say me.parm, the last one for count. And then we're going to set this to a value of 0. Remember that it is not a string or some kind of data array, that count is an integer. So that's why we're putting 0 in there instead. All right, you know me, I'm going to test this just to make sure nothing funky is going on. So let's click apply. And then if I click in here, area this, so if I hit the reset button, uh-oh, aha, see, I did find an error. Okay, here's my error. On line 40, cell not defined. Okay, typo error. I'm going to look under here. Okay, where's line 40? Here's 42. Okay, cell.prim. Okay, it's self.prims. Click apply. Let's try this again. Enter. Let's click reset. Okay, nothing's going on. Everything's cool. All right, very good. So now let's go ahead and then handle this mouse event. So we handled our, if we hit the enter event, we know what to do. If we change the parm event, and it happens to be by clicking the reset button, we've handled that. Now let's actually just handle the on mouse event. And I like to remember things, so I'm not going to copy and paste the code from the Houdini website. I'm going to see if I remember how to do things. So I'm going to go on mouse event. We don't need a capital N there. On mouse event. Okay, we're going to send it self and quargs, just like all the other stuff. Okay, what are we going to first do? I'm going to first identify who I am because I have schizophrenia. And it's going to say, okay, what am I? Say me equals quargs. And inside of quargs, open and close square brackets. Inside of that, open and close double quotes. And inside of that, I'm just saying node. All right, so get rid of my schizophrenia and tell me who I am. So I know who is a, and now I'm going to grab my UI event. So I'm going to say UI event equals quargs. And then I'm going to ask for my UI event. UI underscore event. Okay, this is going to give my event handler. And now, once I have my event handler, then I want to grab whatever state parms I have from this. So I'm going to go state parms equals quargs. And you guessed it, we're going to ask for, put this in open and close double quotes, I'm going to ask for state parms. Okay, so we've got our state parms in there. Oh, that's good. All right. And okay, whenever you do an event, and whenever you have a UI event, there's two things that comes along with it. You get a reason and you get a device. And we're going to need to know what the reason for this mouse event was. And so we're going to grab that. So we're going to say reason equals UI device, UI event reason. I'm sorry, UI underscore event dot reason. Okay, give us the reason of why we're in this in the first place. And now we're going to have to ask for its device. So device equals UI event dot device. In other words, okay, is this the mouse? Is this the mouse wheel? Is this a button? Is this the mouse position? What have you? It's going to tell us what we all want, and this is going to give us some kind of thing. Our information. Okay, so we have our reason and we have our device. Now, here comes the groovy part. We're going to use some ray tracing. What we're going to do is wherever the mouse is, as soon as we press this button, we're going to cast a ray from wherever the mouse is, and it's going to project it onto the geometry surface of wherever that is. Remember, we do know what the geometry surface is because whenever we said on enter, we said, okay, give me the geometry. And so now my class has geometry that it can deal with. So cast a ray onto that. And so we're going to do that with a three-step process. The first is to get the ray origin and the ray direction. So I'm going to say ray origin and ray direction equals UI underscore event dot array. Okay, create array associated with our UI event handler. All right, cool. So I'm going to say geo-intersector. We have to create an intersection object. Geo-intersector equals, okay, we're going to have to call up a method that is listed in a library that we don't know about here, but see, it's called a viewer state utils, SU. So we're going to need to include a library from that. And so let's get that from there. And so we're going to go and say SU dot, we're going to look for the geometry intersector. The geometry intersector. Okay, and then what kind of geometry am I going to need? I'm going to need self.myGeo. Oops, that's cell again. Self.myGeo. Okay, now I don't really know much about how this function geometry intersector, this is a Y. I'm not really too sure how that all works. Geometry intersector. I don't know how it works. I tried to look up the documentation. I couldn't find the documentation, so I actually went into the Houdini source code, and then I found out what the contents of this library, and that's kind of I figured out how it's being used. But it's really just creating a position and a vector, and that's really all that it is keeping track of. But needless to say, what we have to do is we have to grab its intersect object. So we're going to say geo intersector dot intersect. Okay, wherever it intersects, we're going to have to send it. We're going to have to create an intersector object, but we're going to send it the ray origin, and then the ray direction, and then we're going to have to say snapping equals false, because this will keep under consideration the snapping of if you want to put it on the grid or something, if you want to snap the grid, snap the points, it will take under consideration here, but we're going to turn the snapping on by default as off. Okay, so we've got our ray being created right there. Okay, hang in with me. We're getting there. This mouse event is the most complicated thing that we're going to do that. So what we're going to do is, all right, so we're in the mouse event. Then we're going to have to deal with the active state, the reason why we're in here. Remember how I said we're going to have to say, all right, tell us the reason why we're in here. Okay, we're going to have two different reasons here. One, if the state is active, and two, if the state has changed. We're first going to handle what to do when the state is acted, and then we're going to do is if the state has been changed. So we're just going to toss in here, we're going to say if, and then we're going to say reason equals, and we want a who, and we want a, it's going to give me a hint. I'm going to get a UI event reason, and we want active. Hey, there it is for us. Okay, if it is active, then do this stuff. Okay, first, what we're going to do is we're going to say prim equals geo-intersector. I'm going to grab this variable here because I don't want to create a misspelling here. Geo-intersector dot prim num. Okay, now this is going to give us whatever we created the intersection, whatever it intersected, give us the primitive number of where the intersection is. And then I'm going to append this primitive of wherever it is, I'm going to append it onto our string. So self.prims.append, and go ahead and put prim into there. Okay, so it puts it onto the prim list. Now, an interesting thing happens. This is going to be happening a bunch of times, and the cursor is going to be inside of every primitive for quite a while. So it might actually append a bunch of stuff onto the list, and it might be repeated. That's okay, because remember, we are going to reset things to 0 again as soon as we get the first opportunity. But for usefulness, we don't want a whole bunch of things. So we take advantage of some Python-ness in order to help take advantage of this. So actually, let's actually test to see if this works. Let's actually print to see if this works. So print, and I'm going to go prims, and then inside of that, and dot format, and I'm going to go self.prims, self.prims. All right, so this should tell us if stuff is actually working. I'm going to hit apply. Uh-oh, we've got a syntax error. You know I like to do this. So 57 and 19. Okay. So, uh-oh, look at that. 57 and 19. If reason equals, this has to be double equal. That's because it doesn't like the single equals. If I hit apply, yeah, that's what the problem was. All right, now if we go ahead and do this, let's go ahead and hit enter. There we go. Uh-oh, this is error node. Okay, we have a key node error on line 46 on mouse event. Okay, not a problem. So let's go to line 46. And I think I've got a typo error in there again. So let's go to line 46. Here it is, up there. Me, 46, Quargs, node. Okay. Now let's see. Does it not like the fact that I use double quotes on that? I don't know. I don't think so. So let's see what, if I hit enter. Okay, it says file effect. Let's read what this says. Okay, traceback error in wrapper function, opdef on mouse effect key error node. Okay. File, okay, key node, what? Key ergs, Quargs node on mouse event. Is this going to give us any information? It's just saying no. It's just saying, okay, we have got a traceback error, key node, a key error node. All right. Okay, it's going to keep erroring out as soon as I put the mouse in there. So let's escape. And so it's going to keep on doing that. So let's keep the mouse out of there. So let's keep this working here. Mouse Quargs equals node. And so I'm going to just comment this out. And then, nope. All right, this is frustrating. Click apply. And then we got that, click apply here. And now if I hit enter, UI event. Okay, on mouse events. Okay, 47, UI event. Okay, something is wrong with this statement up here, and which means that I could have an error up here on the parm change event. If something is not copacetic, research set count set none on mouse event. Oh, it's cargs. Should be quargs. All right, that's my problem, gang. All right. Typo error. So it's good to do all these checks every now and then, because otherwise I'd just be lost. All right, I click enter. And now if I click onto here, and there's all my, oh God, look at all this. Okay, so this collects all the nodes that you can see it's just getting huge. And a lot of stuff is being repeated over and over and over again, but it is keeping track of all the numbers that I click on here. So that's good. So that's good. So what I'm going to do is I'm going to go over here to reset, and that's going to reset all of my values here because that's what I want. And so getting back to where we was, so we want to clean things up, get rid of all this repetition. Now, how are we going to get rid of all this repetition is what we're going to do is we're going to create a variable, a buffer string in order to put everything onto. And so I'm going to click onto this, and I'm going to say buff for my buffer string equals empty string, double quotes, so there's got nothing in there. So let's say for prim in and we're going to go self.prims, because remember we're building this right, self.prims. We're gonna be building that, but instead of just doing that, we're going to use set. We're going to put this into a set function, and so what this does is it, Python is a little bit helpful for us, and it says it's going to think for us a little bit, and it's going to just get rid of anything that's repeating itself. And so we're just going to, if it has anything in it, we're just going to append it. So we're going to say buff equals, and we're going to go open and close double quotes. We're going to go open and close curly brackets, space, open and close curly brackets. And then at the end of this, we're going to say dot format. And then inside of that, we're going to put buff. So that means we're going to append to itself. And then we're going to put prim, whatever prim is, on here. And now what we're going to do is that instead of prim, we're going to look at buff. So I'm going to type this in and say buff. Okay, permit and format. Buff. Okay, so whatever buff equals, it now should display. Okay, so hopefully it goes a lot easier. I'm going to click enter, and now I'll click in here. Okay, there it is. There's my stuff. Buff is now nice and concise. If I click into that, it starts over. So there it is. So reset. Nice and easy. Okay, everything is working good. I like it. All right, so now we have our selected primitives. So what we have to do? Well, we have to put that into the group variable. So remember how we created it? We exposed the group on here from our group SOP. So all we're going to do is set the value of this group SOP to this buff string that we created. So let's go ahead and append that. So me.parm, and that parm is group. Okay, me.parm, whoops, that's single quotes, dot set, and then we want to just put buff into there. Okay, so that's going to set that value right in there. Okay, let's test to see if that works, because we might be able to get a little bit of feedback. If I hit apply, we should get at least some kind of feedback here into this group variable, because this should get set. I'm going to hit enter here, and I'm going to hit reset, and okay, look at that. It's not doing it right, but it's setting the color to something here. It's doing something, but it is definitely changing color. It's hard to tell what that's all doing, but if I hit reset, all right, then it sets everything over again. I hit reset, and there it is. Okay, then I said reset again, All right, we good. Now, I have to go in and check. I'm going to go in and check to see why my thing isn't printing its color correctly. So I'm going to hit Prim Select and Paint Me. And it's got group -1 in there. Why does it have -1 in there? I do not know. And it doesn't like it. I said, no, sir, I don't like it. Okay, I got a -1 somehow, and it got appended to that. So let's see, set vertex rand color equals, okay, oh, count equals 0, so I say rand color, set vertex attribute supremnum I. So what happens if I put this in here along that? I was trying something else, and I think I think I made an error there. So hit Alt S, Alt Z, and then put the display on here. Hit Enter. All right, that's what I expected. All right, cool. All right, hit reset. And as you can see, that it doesn't click. We have to do something extra to hit the reset. It should just, when we hit reset, it should just disappear there. So let's go ahead and kind of change things up a little bit and fix things up so that it's all working as expected. So I'm going to hit reset and click someplace arbitrarily on there to get rid of it. And I'm going to go to the type properties. So things are working, which is exciting. Now we're going to say if the reason equals UI event reason active, do all this. But let's just say if the event reason equals change, that means something else is going on, like the reset button. So I say elif reason then equals who.ui event reason dot changed. There it is, second one right on there, changed. Okay, then we're going to go ahead and then we're going to do all of this stuff. We're going to do all this dealio. And what we're going to do is we are going to first, if we, what we're going to do is we are going to set the group to nothing. And I think that's where this -1 is coming from. And I think this is where this is giving us the error. So let's go ahead and change that. So we're going to go say me.parm. And inside of there, we're going to put group. So we don't like that -1. I don't know where that -1's coming from, but I'm going to make sure that it's not there. So set, and then I'm just going to put the empty string in there. Open close quotes, double close quotes. Okay, set that equal to that, nothing. Okay, so to get rid of whatever's in group, clean it out. We don't want anything on there. And then we are going to, we're going to increment our count. It starts at 0, and then we're going to change colors all the time on here. So let's go ahead and increment the account. So we're going to do this. We'll say me.parm inside of that, and inside of that we want open close double quotes count dot set. And what we're going to set it to? Well, we're going to set it to itself plus 1. Okay, because we're going to count plus 1 every time. So I'm going to just copy this and put that inside of here. So we got me.parm count, and then instead of saying set, we're going to evaluate it. So eval, and then we're going to go plus 1. Okay, so that's going to increment the count by 1. And then we're going to, I wanted to delete all of my prims again. And we're going to go say del self.prims. And then that's open and close double square brackets. I'm going to put a colon in there. And let's make sure that this is working as expected. Click accept. All right, hit enter. Okay. It's changing colors every single time we do this because what it's using is count number, and that's being used to drive my randomness. So what we have to do is we're losing this information every time, and we don't have any errors. So this is where the feedback loop comes in. Okay, let's remind ourselves what this feedback loop was, because I remember we set this up at the beginning and then we kind of forgot about it. So I'm going to go into the prim select and look in here. This painted geo has it. So as soon as the painted geo has some kind of value, what we want to try to do is we want to update the feedback. We want to set our feedback string not for clean geo anymore. We want the painted geo. We want it to come back up in here before setting all this to 0 again. So this is what we're going to do is we're going to create a way of copying this painted geo and put it up here into the stash. All right, cool. So before we do any of this, before we nuke anything, before we clean anything up, what we're going to do is we're going to call a feedback loop. So self dot update feedback geo. Okay, and then what we're going to do is we're going to send it some kwargs. Oh, just because we might need it. Okay, but this doesn't exist. So let's go ahead and create a new method in our class. Okay, say def update feedback geo, and we're going to go self and kwargs. Okay, so what we're going to do is now we're going to set the value of stash to be the geometry what is ever in painted geo. So very similarly, we're going to say me.parm, and then inside of that, we're going to put open close quotes stash dot set. Okay, what we're going to set it in here, we're going to set the value to be whatever's in painted geo. So we're going to go me dot so we go self dot node, and the node that we're looking for in here is called painted geo. So painted underscore geo. Okay, that's in double quotes. And then we want its geometry. Dot geometry. Okay, cool. Well, that's all it is. All right, so what we're going to do is put the painted geometry inside of stash. Okay, and then what we're going to do is we're going to delete everything. So it should be, and in effect, this should create the feedback loop. So let's click apply. And then click up here. Uh-oh, me is not defined on 73. Uh-oh. So go to line 73. Okay, kwargs. Okay, me has not been set. Okay, so it's just self.node. So what we want to type in here is self.node. It's already been saved to the class, so we have that. So we don't need to identify who kwargs is, but we could get the information from kwargs if we wanted to. I'm gonna click apply. I'm gonna hit enter. All right, no errors. We got that working. There, okay. And we got a feedback loop, and we're just adding upon this. I hit reset, everything disappears, and then we start all over again. All right, we are styling. Not necessarily very sexy, but we've got our viewer state working, and now we can really put some wild functionality with it, of which we were going to have to do at a future time because we are just about out of time here. So let's just go and make sure that this all actually works. So we've got our grid here, but what if we were to use something different, like, oh, let's put the squab in there. Well, I don't know if the squab is going to work, but I do know good old Roberto is going to work, so give us Roberto. Okay, I'm going to pump Roberto in there. Okay, Roberto, let's paint on you. Let's see if this works. I'm hit enter. Oh, I didn't get the stuff. Enter. There it is. There's a reset button. Hit reset. Now let's click on here, and we are painting on Roberto. Go paint on his butt. Paint on his head. Okay, cool. Painting on Roberto. And you can see we can paint on any surface here. And so this is giving us information of whatever we click on. So right now, this painted select thing isn't really that useful. However, we do now have a tool that we can use in the future, which would be really, really helpful. And it's using this feedback loop so that we can just keep on selecting more and more information, and it'll keep on adding to whatever we got in here. All right, really cool stuff. Works exactly like we expected it to. Okay, happy day. All right, thank you very much. Well, that is all that I really wanted to cover. This was, you can see, a little bit more complicated result. Almost took us an hour just to get through by itself. So thank you very much for your patience, and thank you very much for your support. Join us again next week, and I think next week we're going to be doing an interview as part of our Procedural Gems series. We're going to be interviewing Luis Cruel from Side Effects Software. If you don't know Luis, Luis is a really gem of a person. He's really golden. He's a fantastic guy. He is one of the guys who's worked part of the games division, and he is part of the Side Effects Labs, and he is one of the creative guys that is cranking out all of those tools that Houdini Labs are coming out with, and he's part of that tool team. So Luis is a really great guy, and so if you want to have any kind of questions for him, send me your questions, and we'll pass those questions on to him next week. All right, let's see. Before we get started here, before I let you go, I got to remind you, subscribe to my YouTube channel that you've seen this on, okay? Make sure to subscribe to it. And on the LinkedIn, checked out Chris Rhoda and then techartedu. And on Facebook, check out me, Chris Rhoda, and check out the Orlando Houdini Users group. And if you want to make a request or if you want to send a question in for Luis next week, send email to chris@techartedu.com. That's chris@techartedu.com, and we should be able to get going. So thank you very much again for joining me this week. Have a great weekend, and we will see you next week for another episode of Houdini Secrets Live. See ya.